LiquidCrystal is one of the popular standard libraries for the Arduino and has a number of APIs for it. The code for the library is found in Arduino Libraries LiquidCrystal on GitHub and has source code that provides a liquidcrystal.h, liquidcrystal.cpp, as well as a number of good examples. A disadvantage of the current situation is that there are no automated tests for this library, and there's no provision for using this library within the automated test environment. In an earlier video, I presented LiquidCrystal CI, a subclass of LiquidCrystal that included some features that supported automated testing. The way this was structured, however, required you to add 2 libraries to your project. In this video, I present a fork of the LiquidCrystal library that includes testing capabilities built into it. These testing capabilities are based on Arduino CI. The original library provided a single class called LiquidCrystal that had some constructors and then a number of functions, as mentioned earlier. The approach I've taken in this new library is to rename the original class to LiquidCrystal Base and then provide a subclass, LiquidCrystal CI. The LiquidCrystal CI subclass inherits all the behavior of the original and so can be used in place of the original but does not have to replace it. But we'd prefer not to have to change all the references from LiquidCrystal to LiquidCrystal Base. So in production, we can still use the name LiquidCrystal and essentially hide the CI subclass in production. But if we're in test, we want to use LiquidCrystal as the name of the testing subclass, and then you leave Base as the name of the original library. So let's take a look at how we've done that. Our new LiquidCrystal library still has examples copied over from the original and has source, but now we have 2 additional files. The liquidcrystal.h and .cpp are largely copied from the original with a slight change. In the CPP file, all of the class names have been renamed to base. So the original class is now named LiquidCrystal Base. In the header file, we've also renamed the class to LiquidCrystal Base, but we have in it some if-defs at the top. After including Arduino, if there's a mock pins count, then we rename the LiquidCrystal CI to just be LiquidCrystal, include an extra file. If the mock pins count is not defined, then we simply rename base to be LiquidCrystal. So after including this header file, there will be one class named LiquidCrystal and another that's not named LiquidCrystal. In our CI file, we have the CI class with various additional functions in the header, and then in the implementation, we again have the various files. Notice that there's an if-def mock pins count. If mock pins count is not defined, so if we're not in the testing environment, then this CPP file disappears and no code is added to your project if you are not testing. The only time this code is added is if you're testing. Then, when we're testing, we have the test class has been renamed so that it will be the primary name, and the base class still exists and has the base class name. So how do we use that in testing? The way we're doing testing is we have one common file. The common file is written to expect a class named LiquidCrystal Test. Of course, there is no such class named LiquidCrystal Test, but this file is included as a CPP file, which is kind of a non-standard approach, but it's a way of including the entire CPP when we've renamed LiquidCrystal Tests to LiquidCrystal Base. So when we want to test the base class, then we specify to use base. If we want to test the test class, we include just LiquidCrystal, which will have been renamed to LiquidCrystal. So our tests will be of the test class or of the base class. So we're confirming that all of these tests work for both classes. So both classes will accomplish each of these things and prove themselves to be behaving the way they should. In addition, for the test class, we can add other tests so that we can say, create the object that we're going to test, assert that it has one row, and then call the begin function. And then it should have two rows. This shows how we can add tests that will apply to both classes, the test and the base, by putting them in the common area. And we can add features to test other APIs in the base class. When we want to test features of the testing class, the subclass, the CI class, we put those in the test class CPP. Now that leaves us 3 test files, but we're configuring the Arduino CI YAML file so that it does not run the common. So it will run the test class and the base class test. The automated tests will not attempt to run this file, which then can be included from the other two. So in each case, we'll run the common tests against each of the classes. With that, we can open a terminal and say /test.sh. And with that, it will load and run the Arduino tests. So this gives us a single library that can be included. If you're not in a testing environment, it will simply rename the thing that I've named LiquidCrystal Base to LiquidCrystal, and all the code will be the same. There should be no changes. If you wish to do testing, if you're running in a test environment, then it will rename the test class and leave LiquidCrystal Base, but we can still run tests against both to verify the base class behavior and to verify that the subclass has not changed the behavior that it inherits. So the behavior will still be the same for the test class, but the test class will have additional features that allow us to ask what was done and actually look at the value that's being displayed in a programmatic way without having to actually look at it in a physical hardware way.